Now, solve few problems on the Karnaugh Map. In the earlier lecture, we have discussed how to construct a Karnaugh map for 2 variables as well as for 3 variables, and why we go for the Karnaugh maps even though we have the Boolean laws for simplifying these switching equations. By knowing all these things, now let us solve few problems on this Karnaugh maps. To simplify any given switching equation, either in the form of SOP or in the form of POS. So the very first problem, let us take as solve using K-map or Karnaugh map, in short. Y, that is a function of a comma b comma c, which consists of some terms as 0, 1, 4, 5. So this is a given switching equation which has been represented in the decimal notation. This is another form of representing any given switching equation. This simple sum term represents it is a summation of the min terms. So therefore, the solution when you start providing for this particular problem, we have already analyzed the given question, given expression, hence we decided is in SOP form. So as per the procedure, whenever any given switching equation needs to be solved using the K-map, what we have to do, first step we need to construct the K-map and place all the adjacent cells in the matrix form and place the given min terms with a logical one corresponding to each of the min term cell. So this is the procedure. So therefore, to start with, let us construct a K-map. Since it is a 3-variable K-map, so we will be going for 2 rows and 4 columns K-map. And out of 3 variables, MSB variable, I'll be assigning for the rows, and 2 LSB variables I'm assigning for the columns. When the variable values are considered for each column, B bar, C bar, first column, B bar, C, second column, BC, the third column, B, C bar is the fourth column. Similarly, when variable value is represented for the rows, first row represents A bar and the second row represents A. A bar, B bar, C bar, which is representing the min term 0. So therefore, the cell value is 0. A bar, B bar, C represents the min term 1. So hence the cell value is 1. A bar, B, C represents min term 3. So cell value is 3. A bar, B, C bar represents min term 2. So here. Similarly, when the other cell decimal values are computed, A, B bar, C represents 4. A, B bar, C represents 5. Then A, B, C represents the cell value of min term 7 and A, B, C bar represents the 6. So this is actually an K-map that will be depicting a 3-variable. And now After the first step, wherein the construction of the K-map has been completed, in the next step, substitute the min terms into the respective cells, corresponding cells with a value of 1. When we are representing a value of 1, so the given expression has the min terms 0, 1, 4, 5. So therefore, what we need to do, to the corresponding cells, we have to place the min term with value 1. Okay, now we have to place 1 into the respective 0 cell with 1, cell number 1 with 1, cell number 4 with 1, cell number 5 with 1. After placing the corresponding min terms into the corresponding cells, in the next step, we need to group all the adjacent cells. While grouping, please remember, while grouping, first thing you have to remember, only adjacent cells needs to be combined, to be grouped. And another important point you have to remember is that these cells while grouping, you can group in terms of multiples of 2. Either 1 cell or 2 cells or 4 cells or 8 cells only can be grouped. When a single cell grouping you observe no redundancy removal is possible. Okay, when two cells grouped, possible to remove one variable. It's possible to remove one variable. Similarly, when 4 cells have been grouped, it's possible to remove 2 variables. When 8 cells have been grouped, it is possible to remove all the variables. Hence, the value is 1. The result will be 1 in such case. Because in this particular 8 cells K-map, all the 8 cells when they are grouped, it is possible to remove all the variables. Hence, such removal of all the variables you can represent, depict with a value of 1 as the output. Now, coming back with all these information, coming back to the simplification or grouping of this particular expression K-map. In this K-map, we have 4 adjacent cells. 0 is adjacent to 1. Similarly, 0 is adjacent to 4. Similarly, 1 is adjacent to 5. And here, please remember, diagonal grouping is not allowed. Only adjacent cells needs to be grouped. Hence, when all these 4 cells have been grouped, what is the output that we are going to get? For that, let us see the 2 columns. In both the columns, we have B bar, C bar, B bar, C. So C and C bar are the redundancy variables we have seen between the cell 0 and 1. So therefore, you have B bar as the common. If the rows are being considered, in the rows A bar and A. So therefore, it is not possible for us to group or retain any variable because A bar and A, it satisfies the Boolean laws. So hence, grouping such 2 variables corresponding adjacent variables row-wise will remove the A variable. Hence, the output what we'll be getting for Y will be equal to only Y bar. So if you compare this process with respect to the Boolean laws process, you can easily decide that this K-map is the simplified version which can be adopted for any complex switching equations to simplify and to remove the redundancies. So this need not be only with min terms, even with the max terms also you can consider to simplify. In the next class, I'll be discussing the implicants and the prime implicants which will be used in K-maps.